These are notes for acids and bases worksheet number 1. Acids that you might eat have a sour taste. Oranges, buttermilk, lemons, Sour Patch Kids. Bases tend to be bitter in taste and slippery to the touch. Soap. Would you eat soap? Chocolate? Dark chocolate? What is a proton? A proton in this chapter refers to hydrogen plus, meaning it only has one proton. A proton is considered to be acidic. Bases are mostly composed of OH, which are not acidic, but there are other substances that create basic solutions, for example, ammonia or ammonium. Arrhenius, a Swedish scientist who taught himself to read at the age of 3. In general, H+ ions are acidic and OH ions are basic on a pH scale according to Arrhenius. Arrhenius acids produce H+. For example, if you have nitric acid, when it splits up you get an H+, and the NO3 is the H+, that is the acidic part. Arrhenius bases produce OH ions, so if you have sodium hydroxide, the basic part of it is the OH. Arrhenius was erroneous. Arrhenius acids and bases are restricted only to aqueous solutions. This means that solids cannot be acidic or basic, and you know that solids can be acidic or basic because you eat Sour Patch Kids. The outer coating is a solid. The Arrhenius definition only allows for one type of base, the OH-. This is not true. There are other substances that are basic. So Bronsted-Lowry acids and bases. Johannes Bronsted, he was a Danish chemist, and Martin Lowry was an English chemist, not R. Martin from the videos. Acids are proton donors. So he said an acid gives up or releases some kind of proton, which is an H+. The H+ is what makes the solution acidic. The Cl does not affect the acidity. He said bases are proton acceptors. He didn't say they were OH donors. He said they're H acceptors. For example, you have ammonia taking H from some source and making ammonium. This definition has broader implications than Arrhenius' definition. Where does proton come from? What really happens when an acid is dissolved in water? So you have an acid and it's in water. What really happens is that the water manages to take up the H that is separated from the Cl, and the Cl is still by itself. So the water becomes a plus because it has added a plus item to its neutral self. H3O+ is called a hydronium ion. I'm tired. Generally, it is shortened to H+ because that is the part we're concerned with, although it can be written as H3O+ and called hydronium. Conjugate acids and bases. So let's review. Acids start with the letter H. Bases in general have OH in them. Conjugate acids and conjugate bases come in pairs, and they are written on the right side of the equation. So every acid has a conjugate base, and every base has a conjugate acid. A conjugate acid is what results when the base adds one H, and a conjugate base is what results when an acid gives up one H. So when an acid gives up an H+ to become a conjugate base, the conjugate becomes one more negative. For example, here's the acid. When it becomes a conjugate base, it loses an H, and it's Cl-. When a base accepts an H+, it becomes one more positive. For example, NH3, if it takes an H, it becomes NH4+. Let's do some practice. Find the conjugate base of the following compounds. So conjugates from the original will lose one H. Oh, rats. I gotta get the thing to show up. There we go. So write the conjugate base of the following. We got ourselves a red pen. So we're going to lose an H. It appears that my pen has decided not to work at this moment. So we'll end up with a Cl and a minus. And if this loses an H, it'll be a Br minus. If this loses an H, it'll be an NO3 and a minus. I'm writing with a mouse, so this is lovely. If this loses an H, it becomes Cn minus. And if H2SO4 loses an H, this one looks like a trick question, it becomes HS, giant S, O4 with a minus. Now find the conjugate acid of the following compounds. It means that they gain one H. Let's do this. We could erase those ones we had before. Oh, rats. Again, we need to get the list up here. There we go. So they gain an H. So if H2O gains an H, it's going to become H3O with a positive. If ClO3 gains an H, it becomes HClO3 and it's neutral. If HPO4 2- gains an H, it becomes H2PO4 with a 1 minus. If NH3 gains an H, it becomes NH4 with a positive. Identify the acid, base, conjugate acid, and conjugate base in the following. So acids and bases are on the left-hand side, and conjugate acids and bases are on the right-hand side. So acids lose an H. So let's look at this. From there to there, HCl lost an H, so that makes that the acid. From here to there, water gained an H, so that makes it a base. Every acid has a conjugate base, and every base has a conjugate acid. And what that means is if you go backwards, this acts like an acid because it gives up an H to become that. And if you're going backwards again, this Cl gains an H to act like a base. So they're the conjugates. Let's do this one. So I'm going to find NH4 and its pair, or NH3 and its pair. NH3 and NH4 look like a pair. In fact, I'll link those up. And then H2O and OH look like a pair. So I'm going to ask myself, NH3 to NH4 gained an H, so this must be the base, which would make that the conjugate acid. And this one, H2O to OH, lost an H, so that means it's the acid. And by default, that's the conjugate base. Again, conjugates are always on the right side, and the non-conjugates are on the left side. Those are the end of the notes for worksheet 1.